Well, hi, good morning. Thank you so much for joining me in my shop. Today is June 27th. You know, when I say in the morning, thank you very much for joining me in my shop, I really do mean that. The fact that you are there watching this video, even though it's not happening at the same time, it's happening hours or even days later, removes the lonely feeling that someone could have if they're working in a shop like this and struggling with these kinds of projects. A lot of these projects take you into zones you haven't been in before, where your knowledge may not be so great, and the next thing you know, you're flailing, and it can be very, very frustrating, and you can also be left with the feeling you just don't know what to do next. And all these things are very demotivating. But when I have this camera running, I can't let that demotivation take hold. And so it makes me a little more resilient, a little more willing to keep pushing and to try to sort things out, where in other circumstances, if it were just me all alone here, I might just throw in the towel. And you know what, if you throw in the towel, you feel bad forever afterwards. So I mean, there is a risk here. You are risking your feelings about yourself and your own capabilities when you take on a project like this. And it's not just radios, it can be anything. It can be construction projects around your house and that. And things go wrong and you start feeling terrible. So at least if things go wrong and I'm feeling terrible, there's somebody watching me feel terrible on the video. So once again, in all seriousness, thank you so much for watching these videos. And also the comments you make, although I don't read many of them because it's just too much. I am aware that at times great discussions take place on my channel, and I'm not really encouraging it or discouraging it. I'm just letting it go the way it goes. So great. Okay, what about this radio? So my philosophy in fixing a radio like this is to get it working to any degree as quickly as possible. Most radios come in, they are working to some degree, and what I mean by some degree, would mean if the radio is operating and you fiddle around with the antenna, you hear effects coming out the speaker, something like that. Anything like that, just to let you know, there's a signal path all the way through the radio, all the way to the speaker, makes the situation completely different. And I'll explain that. Right now the radio is dead. If I decide, well, you know, there's a bunch of old capacitors underneath here, let's change them out, and I go ahead and do that, I never heard the radio operate. When I get all done changing those capacitors, the radio may not operate. Now what? Did I make a mistake? Did I make a mistake putting the capacitors in? Well, if it's me involved, the answer is yes, I've made a mistake. But you know, you wouldn't even know it because the radio didn't work in the first place, and whatever was wrong with it then is still wrong with it now. And you get yourself into a terrible jackpot by introducing problems you don't realize you're introducing until the radio becomes a rat's nest of mistakes. The thing about making an error, say installing a capacitor, and you stick it on the wrong lug just by accident. You looked away for a moment, when you look back, it looked like this, here on it went, there it is. Now the radio no longer matches the schematic. Its behavior cannot be properly analyzed by analyzing the schematic necessarily, and so it becomes really difficult to find your own errors in a radio like this. So what I plan to do today is make it work to some degree before going any further. That might involve changing a few parts here and there. A little bit of guesswork may go on here too. With a dead or very, very quiet radio, the first thing to be suspicious about, beyond effective tube, is no B plus in the radio, no high voltage in the radio. So I think the first thing we want to look at is the power supply, what's going on with it. We already saw that it looks like it's got two new capacitors put in it. This is very, very solid here. Thinking about just turning the radio upside down, but unfortunately it would sit right on this tube here, which we don't want that to happen. So we'll stick it up on its end. We'll put the heavy end down. Transformer's in the middle in this radio, so the speaker will be the heavy end. Okay, doing a B plus test very easy, because here's the two filter capacitors, and we're just able to touch the voltmeter to them and see what's on them. I think that's really the first thing to do. also need to stick my ear right up against the speaker and see if there's anything at all coming out of it. We're going to do this without an antenna connected. Some radios become very, very quiet when there's no antenna on them, especially if the radio's a little weak. Okay, I think we're ready. Dim bulbs. This time I have both light bulbs screwed in, so not as much power went through this bulb and it barely made it glow. That's okay though. So we're around a little under 100 volts. I gotta get a voltmeter. Okay, I'm going to do the listening test here. Let me just make sure these tubes are warming up. Yep. So there's a hum in the speaker. Now this speaker has a field coil and a voice coil. And the field coil could be generating the hum. So that's the first sign that there is B+. Let's see what's on this capacitor. This would be the positive end. 170. And the other one, I guess right here. 216, so that's pretty healthy. Is that getting out to the tubes? So we're going to pick a tube, any tube, and just poke around and try to spot B+ on it. There it is there. Come down around the output tube, which is right here. Oh, I already got it. He's muttering. Just guessing. Just poking around and looking. These ones are buried under here. Oh, there we are. 187. So B+ on the output tube, and right on the front end tube here. So this looking for missing B+, not working out. There it is there, 187. Okay, do a little signal injection here. Because the tubes have grid caps, and be aware some tubes have plate caps, so you don't want to do this on a plate. On a grid, I have a signal in me, and I'm going to inject it into the radio. Let me just, the volume is up full, so I'm going to turn it down just a little bit here. So the fact that I can touch this and we don't hear a thing implicates this tube and the circuit beyond it and this tube. But I've tested the tubes. So we're going to move up even further. I'm going to try to touch the grid of the output tube and see if that makes sound. And the grid of the output tube, I believe my book here. What was that output tube called? Does anybody remember? It's on the sheet in there. Just bear with me a second while I peek at my own. Here we are. So 7B5. 7B5, and they have not written the pin numbers on the schematic. Why did they not do that? 7B5. So the grid is on pin number 6. Grid is on pin 6. So what I want to do is first touch it with a piece of metal here. This is a rather big screwdriver for this. But we'll do it. What pin did I say? Oh my gosh! Don't close the book this time, Jim. 7B5. I'm very doubtful of my memory. 7B5. I have trouble remembering that I'm doubtful of my memory. 7B5. 6. Keep it open. Pin 6. Okay, pin 6. The idea here is I'm just going to touch it with a screwdriver, and we should hear some clicking. So pin, oh, how do you number the pins in this kind of tube? Let's say loctile tube. Same as the other. 1, 2, 3, 4, 5. Well, I think this might be 6 here. Let me just jam this great big screwdriver in here. Let me hear a thing. A thing. Okay, we might have a bad speaker here. So it has an output transformer. Looks perfectly fine. There's no magnetic field there. Shouldn't there be? Feeling for heat. No, I think this is warming up slightly, which means there's current flowing through that. Since I didn't seat this tube all the way, or this one all the way. Okay, let's turn the radio off. Let's just check and make sure the speaker works. And what I'll do, there's usually enough magnetism left in these that the speaker will operate even without the field coil energized a little bit. Can we just do this? Can I just do this? So stick this on conductivity. That should put a little voltage available at the leads. Can't we just touch the voice coil and see what happens here? Can't see what I'm doing. The open output transformer. But I saw B+, did I not, on the output tube? I don't know if this will work. I'm not looking for the beep, I'm looking for scratchy sounds. So it's showing continuity either in the speaker voice coil or in the transformer. In the transformer probably is what's causing the meter to beep. And I'm not able to energize the speaker at all that way. Get any kind of test out of it. Let's try something else. Let's try using this guy here. So this is an audio signal generator. It has its problems too. Like all my vintage equipment has a little bit of trouble here and there. So we need to initially test this to make sure there is a tone available. So let me grab a speaker. I opened up some drawers in my garage, and to my surprise, full of speakers that somebody gave me some time ago and I forgot about. All kinds of real old speakers. So we're going to test to see that there is a tone first. Because I know this speaker is good. So we're on the B scale, 200. So if I put it here, about 1,000 hertz. Oh, there we are. So there's 1,000 hertz. Good. Everything working. Now we're just going to transfer the leads from one speaker to the other. There it is. So that indicates the voice coil is operating. That indicates that we're not hearing any sound out of it. It's not the speaker's fault. We need to find out if the primary leads here are also capable of driving the computer. That's the speaker. Find these two wires down underneath. These two wires here. Okay, easier than I expected because there's nothing in the bottom of this radio. So the two, yep, I got them. These two. So one of them, again with the radio switched off, we're going to just try to feed a signal right into the output transformer, the primary side. The other wire is going where? Oh my gosh. Yeah, like four wires all crossing each other like this, and they're all pretty much the same color. Right in this one spot here. You really can't spot the end of the wire. How do you like that? That's crazy. Huh. I don't know. Is it here? See, I can't do a test like that. Guessing like that. We gotta get more certainty here. Okay, calm down. Trace the wire more carefully. Move this out of the way. Okay, so that's definitely going by where I thought it was going. It's actually going by. I'm pretty sure it's ending up in here. Let's try the other wire. The other wire. Oh my gosh, I just can't believe how bunched up they are here. I think they're side by side. The pins. Fall right over. Yeah, this is ineffective, totally ineffective. I'm not going to be sure of it. We need to use an ohm meter and try to ohm out the primary side of the output transformer. Let's look back at the schematic here. So I was trying to spot this wire and this wire. You can see one is the screen and the other is the plate, and that's the normal thing. If I look at my book here, 7B5, so the plate is 2 and the screen is 3, 2 and 3. They're side by side, plate and screen, 2 and 3, pins 2 and 3. Pins 2 and 3, so this is 2 and 3. Okay, look back at the radio now and try to make this work. 2 and 3. Two and 3. And what did I do with the flashlight? There it is. 2 and 3. That would be 1. That's the 2 pins I've been trying to contact. 2, don't fall over right now. 2 and 3. Uh-oh. Uh-oh. This is not a good sign. So I'm looking at the meter, and the meter is just showing nothing. That's what you'd rather see, something more like that. Oh. So I need absolute proof positive that this is the case with this radio. The speakers I mentioned that I have aren't little ones like this. They're in the output transformer, no. It's a very bad sign for this radio. You want to be absolutely sure of it. Pry these wires apart here. Okay, so there's a green one that I'm interested in, and it comes by. And if I could see the conductor soldered there. Okay, so that's settled. So one of them's definitely going to the terminal I tested. The other one is just out of view here. There it is. And I can also see the end of it. And it's going to the terminal I tested. So I tested the 2 terminals that feed the output transformer primary and with both a signal. But I don't know if that really worked. And my ohm meter tells me it's open circuit. Let's repeat the test. Because this is almost a death knell for this radio. This is just about the end of the road already. It's kind of sad. But that could be what's happening here. I don't want it to condemn something on a whim. Okay, so we're looking at this terminal and we're looking at this terminal. And we're going to go up, because maybe it's more than 600 ohms. Still nothing. Okay, I'm going to short the leads. Yeah. Making sure of contact. Looking for any reason. Well, there's a reason right there. I got the 2 probes on the same terminal and it's not showing anything. Is it because there's some weird about this? Okay, so a little, might be dirt on it or something. I don't know why it wouldn't work. Let's push harder. Come on, meter, do your thing. I'm testing the transformer now. Just any momentary little thing there. Show me anything. Nothing. Oh, come on, man. Come on. You can do it. Come on. Well, I think we got a big problem here with this radio. Big problem. The transformer that feeds the speaker appears to be shot. There's no way any sound's going to get through the radio to the speaker. Another way of testing this now is to see if the radio is working all the way up to the speaker. Maybe it is. Maybe if we just do a little thingy. Ooh, look what I just spotted. Can you see the copper there? Oh boy. You can see the plastic it's coming, the rubber is coming into contact with something. Ooh, is there any other spots like this? It's not plugged in and turned on, is it? No, it's not turned on. While I'm doing this. Could we find out if the cord can electrocute you or not? If you live, the cord passes the test. No, this just, how did I miss that? Because it's in a weird spot. It's just out in the middle of nowhere. This section of it was taking some kind of attack. Okay, well, the one conductor is completely good. So what I got to do, I'm just going to throw some tape over that, so it's not dangerous for me in here, or my cats. You know, my cats come in here. Hey, where are the cats today? They're sleeping upstairs. late night? Were they up all night? Okay, so that'll make that safe enough to carry on here. Okay, glad I spotted that. Even though the radio's in such serious trouble. So I think that's what we'll do. We'll run the radio and we'll look for the signal coming through the radio right up to the point where the output transformer carries it. And if we find the signal is all the way there and then not coming out of the speaker, then we've verified the problem in a couple of different ways, just to be sure. So if we look at the tube before the output tube, this is where the audio starts. This part's all radio signal, this part's audio signal. Right in here, this is the first audio amplifier right here. And the volume control is down here. So out of the volume control comes audio that we can listen to, goes to the grid of this tube, comes out amplified and heads to the grid of the output tube. This is pretty easy for me to touch because this is a cap on the top of the tube. So we can listen to what's on this line here from the top of the radio very easily. We'll see if it's picking up some radio here. I have a amplifier I can use for that, a signal tracing amplifier. Like just about everything in my shop, including me, things are a little vintage here. So this is a signal tracer. Put this up higher out of the way. This guy here. Turn on. This is basically also a radio. So it's a radio and an audio amplifier. I have it set to be an audio amplifier right now. So there's no tuning to it. Okay, this is the input. I'm going to put this on the chassis here. Radio's not switched on yet. And there we are. All I got to do, very simple. The wire's a little short, so let's move this over here. All I got to do is that. And listen to what we get coming out of here. Is there any radio signal there? Of course, the radio, I don't know what it's tuned to, so it may not be tuned to. It almost certainly isn't tuned to a station. I don't know if you can hear that cat growling out there. The black cat. I can hear it. No doubt just up the stairs are one or two of my orange cats. And the black cat is looking at them. Warning, don't you come near me. For some reason. Okay, now, so we have antenna connected, and I think we're going to plug it in here. Okay. By the way, the projects that are on my bench are fed through a isolation transformer, which means it's very difficult to get a shock to earth from the stuff that's on here. Not impossible at all, because a lot of my equipment here, all the equipment here is grounded. So as soon as I bring a ground lead from any of the piece of equipment and connect it to the, let's say, the chassis, then this thing is as good as grounded, and I can get ground shocks. But just so you know, it's no big deal. I wear rubber-soled slippers in here. I'm standing on a rug, which is also has a rubber base on it. Most rugs do. And that's on ceramic tile laid on cement laid into the ground. So I think I'm not at all grounded when I'm standing here. But, you know, I have hands, and it's pretty easy to be touching something and then get a shock. So just so you know a little bit about what I'm doing here, I am taking steps to preserve my safety, which I don't talk too much about. Okay. Radio's on, is it not? Yes, tubes are heated. Unfortunately, this my signal tracer over here has quite a hum in it. So I have the ground connected. So we will touch it here. Let me grab the volume control.
Amateur. eyes, and I see oceans of garlic dills.
Well,
You may be experiencing wing sanity, a side effect of all-you-can-eat wings at St. Louis Bar and Grill. And my naps.
if the primary of the output tube is open, and then there should be no, excuse me, B plus on the plate of the output tube. Let's look at the schematic here. So B plus is coming up from the power supply down here on this line. Goes through the primary of the output transformer where I think there's an open circuit now. If it is open, then there'll be no B plus up here. All we got to do is just touch this with a voltmeter and see if there isn't a couple hundred volts there. So that tube, once again, it's a 6 to 7B5. 7B5. Okay, 7B5, and the plate is pin number 2. The second one, pin number 2. Pin number 2. So we'll make a voltage measurement there. Expecting a couple hundred volts or something like that. Okay. Output tube. What pin did I say it was? It was 2. Don't forget now. 2. Okay. Now we're gonna try to spot it here. I need a little better lighting. Voltage on the plate, pin number 2. On the plate of this one down here, pin number 2. I think this is pin 2 here. 1.4. And this would be the screen. We get voltage there? Yes. So you see, voltage on the screen, nothing on the plate. That verifies an open transformer. I'm just going to show you the schematic once again. So what I did was I tested from here to ground and from here to ground. This 0 volt, actually 1.4 volts, that's, who knows what that is, 1.4 volts. And here, full voltage. And all that stands in the way is this. Open primary circuit in the output, output transformer. Well, that's bad. That's very, very bad. How do you get around this? So this speaker is not a permanent magnet speaker. It needs this field coil carrying current. I'll take that back. The field coil is carrying current. That would be probably showing down here. There. This is the field coil here. The voice coil. This is probably a humbucking coil. And this is the secondary. And all this is probably good. And just this. Well, have I got something to replace this? I really don't. Okay, gotta stop and think about this situation now. Okay, able to think a little more carefully about this. So, the typical problems in a transformer have to do with the connections between the internal wire and the external wire that's coming out. Now, a lot of transformers, there is no connection. They actually bring out the internal wire right out, and they make connections in the radio with the actual internal wire. We'll probably see that on here. So if it is a connection problem, maybe there's something that can be done about it. So I want to take a good look at this. Joined by my cat. This is Bert, in case you're new to my videos. Many of you are. This is Bert. He's got a look-alike brother named Wally, who comes in here too. Okay, that's the output transformer. These are the primary wires coming up from below. There's no continuity from these wires through here. So this is clearly not the wire that was wound inside here. So there's a connection between this wire and the wire that's wound inside. If you look at the other end, and now it's hard to tell, especially from the distance of the camera, but these two wires here, which are coming out of the other side, this is the secondary side, or secondary wires, these are actual winding conductors. They've had a sleeve slid over them, and then they're soldered to the voice coil terminals here. So these are the actual winding wires. These are not. So there's a connection in there. The transformer is held together in a very simple way. You can see a bent tab here. You bend this up. I'm just looking at it and figuring this out. I don't have prior knowledge of this. Bend this one up, then you can fold this out and take it off. Then this plate is gonna slide out. Now, at what point does the transformer get totally ruined doing that? Well, we could consider it totally ruined right now anyway. There's no way there's a break in these wires. The problem has to be inside here. And almost certainly it's the terminals. So this is a pretty easy transformer to take apart. Let's go a couple steps that way and see what happens. Again, there's nothing to lose here. Unless this problem's solved, this radio is just going to be a shelf sitter, nothing more. Can I take this right off? How have they got it mounted onto the speaker? It could be that this is the mount. This is a plate that's mounted or welded or whatever to the frame of the speaker, and they take this off. There's really nothing holding any of it on here anymore. Isn't exactly the best angle here. So we're gonna just get a couple tubes out of the way. Oh yeah. Taking these lockable tubes out, you look for one of the rivets, and then you bend the tube towards the rivet, and it pops out. Easy as can be. Okay, now I can get my pliers in here. Oh my gosh. Oh, that's a toughie. That is tough. Wow, how am I going to do this? So I'm going to pull out a tool that this tool was around in my house when I was a kid, when I was 6-7 years old. And here it is in my hands now. Made in Germany. Alloy steel. Good German tool. Okay. What I'm going to do with it? So I'm hoping to get a grip. Like so. So these tabs, you can usually bend them, like you bend them down the first time. You can usually bend them up, but bend them down, they break off. So this is a bit of a one-way trip here with these tabs, but we'll worry about those worries later. Oh, that one broke right off already. Okay, well that should make it easier to get. Oh yeah, the whole thing is coming off. I don't really want the whole thing off though. I just want this top part. The whole thing comes off. I'm going to have to desolder these. I'm trying to avoid that. I'm trying to do this as usual, the easiest way possible. Maybe the whole transformer is going to just disassemble right in front of us here if I take this off. Come on. So this will be the first time I've ever done this, by the way. have the cover plates. They have the core. The windings are hidden inside. So I think I can slide this plate off if I bend these stiff wires. Probably bound to replace. If I make this work, I'm probably bound to replace these anyway, down to here, or maybe even right under. So I'm going to bend them here. Probably the insulation's going to crack right in the hole here and get wrecked, and become a problem in itself. I may have already fixed the transformer by bending these. It may be functioning again. Son of a gun, what if that's happened? Well, it wouldn't be very reliable. Can we just pop these off? Well, this is not as easy as I'm thinking. Yeah. It looks like there's glue in here. Okay, it is popping off. Story continues here. Okay, so I'm able to slide that right back. Now, they have a look down at this here. You see there's a big gap in here. So this is the internal part. They've got something in this gap, and then they've wrapped this around the outside to make sure it doesn't contact the steel cap that I just took off. Under here will be the connections that I'm after. And again, this is just a shot at. I mean, it doesn't necessarily mean those connections are the problem. And it could be that just in manipulating it here, it's already made contact again, so we have trouble recognizing it. So the only way to get in there is to cut this off. Perhaps it's time for the Swedish fish knife to come into play here. So I have a Swedish background, but that doesn't mean I was born with the knowledge of how to manipulate a Swedish fish knife with great skill. Not taught in Canadian schools. Swedish fish knife techniques not taught here. Do this kind of like one layer at a time. Well, I'm doing it one layer at a time. It's not really my intention. Okay, we see some windings. I've slipped this knife right down past windings here. I didn't expect that to be the case. Something more going on here. Unexpected. Where's the terminals? The terminals are not visible. Wow. I hope I didn't cut any of these wires when I slipped the... I'll blame it on the Swedes and their stupid knife. No, I think they're okay. We should check the continuity again after doing this and just see if it hasn't returned just by just kind of by accident. So we need my well, it wouldn't be by accident. I would say unintentionally, maybe unexpectedly. Okay, it was 2 and 3 on the output tube. Well, I could do it from the top now. 2 and 3 on the output tube. I think it was these ones, wasn't it? I'm going to do it from the top. I'm going to do it from the top. Counting from the top, we go the other way. 2 and 3. So this would be, if I can pop these right in. Not quite. I can make contact, I'm pretty sure. Watch the meter now. Oh, let's put it on resistance. Open circuit. So there's always a chance that a winding has opened somewhere inside the transformer. I'm going on the basis that there's a good chance it's just a connection. Opening this up makes me think, no, you know what, like it has not been subjected to moisture or abuse or anything like that. There's a piece of foam shoved down here. A piece of something. That's a little odd. I wonder what that is. Okay. So we get more and more aggressive with this. Not too fast now. It's a digital meter. For sure I've got this right. 2 and 3. Pretty sure I've got it right. Well, it's not coming back. And so that would suggest it's not the connections, but look, I don't even know what I'm doing to these connections. I don't even know where they are. They're deeper inside the transformer. Wow, this didn't work out at all. Let's take a close look at the windings. What are the chances that the defect is right there to be seen already? And all I got to do is just look. Okay, let's look. Kind of odd how the winding is spread out, a little at the top, a little at the bottom, and then these ones in the middle. I wonder if that's it. I wonder if this is the secondary we're looking at. And that's why the wires are disappearing, because they're going further in to reach the primary. And the primary, maybe it's this internal one here, and they're down there. Look, there's a wire right there. Oh, crap. Yeah, I don't think I'm going to be able to fix this. Now, there may be people out there who can take one of these completely apart and rewind the whole thing, and presto. A better approach at this time is an alternate. An alternate output transformer. Of course, they're specific to the radio involved. And what would, you know, there's impedances involved. There's ability to carry current. This is a very small one. Probably not too demanding in terms of current flow through the primary. Well, do I have another speaker that I can wreck and get the transformer from it? Well, that's a good question. Do I have one to wreck? Well, I scouted around a bit to see what I might have that might be an alternative to the situation here. I couldn't find anything. So I might just require more scouting. But for now, I don't think I can do much with this radio. But there is one interesting possibility, and it has a phono input. And in some of these radios, this is as much an output as it is an input. But let's look at the schematic and just see if by some chance the audio signal might be sitting right here, and it could be fed to an amplifier. Let's take a look at that possibility here. So the input is going to be somewhere around the volume control. Where's the volume control? There's the diodes. Where's the output? Here it is. Here it is. Phono right there. So let's see. It looks like the phono. Well, this is an interesting arrangement. Usually, this suppressor grid is grounded out, but in this case, the suppressor grid is attached here. What are they trying to do here? On this wire will be the audio coming from the radio and also some DC. Just a second, I have to see what my cat is up to. What are you doing? Oh, just playing with hangers. Carry on, cat. So the RF and audio can be snuffed out here. No, the RF would be snuffed out here. You can't snuff the audio because it's heading for the volume control. So if you can pump audio into the top of this volume control, it'll come out the speaker, and look where the connection is. Right here. So audio into the volume control, audio into the phono jack, which means I could plug an amplifier in here and the radio would work. It would work entirely, except the volume control. The volume control would not affect. This would be full output, basically. Now that's kind of weird when you think about it. What do you mean? You're going to be feeding the radio output into your cartridge while you're trying to listen to your record player? Yeah. It does seem kind of weird, doesn't it? And, you know, this is a suppressor grid. It's not usually used for much in terms of signals. Some engineers do funny things with these tubes, so this is an unusual connection. Are they trying to amplify the audio? I don't think so. This is an RF coil. They have to transfer the audio through this, and they can't because this is an RF coil. It won't transfer audio. At least it won't transfer it very well. So no, they aren't going to be trying to make the phono cartridge drive this like a signal grid and then amplify. No. It's got to be heading this way and then off to the audio amplifier here. Now what that means is, yeah, I should probably get out a voltmeter, look for voltage here, and then we'll try using this as an output from the radio. We'll see what happens. Okay, I think we're ready for this experiment. The amplifier I'll be using is the same amplifier you're listening to me talk through. So this will just be another input to my little soundboard over yonder. We want to measure the voltage here before plugging it in and sacrificing my entire sound system here, ending my video career. So we're going to put this in. Some of these phono plugs actually have a switch built into them. I didn't see it on the schematic. Let me take a look here and just see if it's... No, there's no switch on this one. You can sometimes recognize the ones that have a switch. The phono plug that goes in there has a longer point or shaft on it. Longer. This is much longer. It looks crazy, in fact. And it's going in far enough to open up a switch while making contact. Okay, I think where's that here? The antenna's connected. Voltage, we want to read the voltage. So we're going to do it with this and my voltmeter over here. What I expect is a couple of DC volts to show up and not much more than that. So we're going to flip this over to, let's say, 60 volts DC. Everybody ready? And the volume, not that it matters much. Volume's down. Here we go. Dim bulbs look the same as before. Oops. Heaters are heating. Now, the voltage here is dependent upon a station being received, the few volts. What I'm really worried about is that there's some disaster happening here. A couple of volts I'm not too scared with. Well, let's just try this. 0.9. Notice it's negative relative to the chassis, which is ground. So that's the AVC voltage coming. That's pretty interesting, you know. The AVC voltage is available at the phono plug. If I just make this a little neater here with some clip leads. Doing a little experiment here. That means if you were to plug a high impedance meter, you wouldn't want to plug a low, like an old meter. You want to plug a high impedance meter in here, you could have yourself a tuning indicator right there. Okay, and we want to clip this to the other end. Here's the other end. Red one. And we're going to put the black on black so we can... This is just going to ground, so I'm just going to clip this one to the chassis somewhere convenient. Over there. And the red one we will put on here, and we should see the same little voltage. There it is. Good. Now if I tune the radio, as I cross stations, this voltage should go up and down by tuning the radio here. So we'll go back. It could be noise. Okay, the voltage is nothing too dramatic there. Okay, I'm at the end of the run, that's why. So we're coming up. There's some strong stations up here. Maybe this doesn't work. Okay, well, the voltage is small. Is that enough to damage my stuff? I don't think so. So I'm going to plug this in. I'll plug it into the... so I have microphone inputs on the back of this board, and I also have line inputs. I'm going to plug it into the line input as best I can. Okay, it's in. This is the volume control for the radio. This is the cat that's made everything more complicated. I don't want you going through here right now. I gotta put the headphones on so I can hear what you hear, because I don't listen to the actual program when I'm in here. Okay. Hello, hello, yes. So the volume in my headphones is very low, and the cat is walking on my keyboard. Still operating? Yes, we're still operating despite that. Okay. Now, with the cat fight starting up behind me, we are going to, so this is something for a project later today. Play around project. Look at the cat situation here. One on the radio, one at the bottom of the stairs, hissing at one that's on the stairs. Shadow. Shadow. Come here. Yeah. No, I wasn't calling you. Are you ready now? This got to be warmed up. We're going to turn up the volume level. That's why I had the camera over this way. Yeah, just park yourself right on the keyboard there. Here we go. What do we hear? We hear nothing so far, so we'll leave it up. Now, danger. If something could happen here, and suddenly there could be a huge blast of sound. So bear that in mind. I'll turn up the volume here. And nothing. We have nothing. Now you'd think the radio designers would want it to be this way, so nothing's coming out of there. But you know what? I'm going to put it on the microphone input over here. And have I already fried my sound system? No, I have not. Did I really plug this? I plugged this into the wrong spot? Oh my gosh, it's possible. I did. I plugged it in the wrong one. It's in this one. There we go. Good show, Jim. You caught that mistake. Volume having no effect. So the volume is controlled only over yonder, and it's full. So we're going to put it into the microphone input because there's almost no volume here. So down on the volume. Okay, this should be a lot louder.
Is now on stage and audiences are going wild, declares the New York Times. It's a jaw-dropping spectacle that hits all the right buttons, raves USA Today. When this baby hits 88 miles per hour, you're going to see some serious entertainment. Back to the Future, the musical at the CAA at Mervis Theater, July.
Attack it from so many different angles. JDM, what do you think?
I think we are unraveling a lot of the Trudeau mistakes on this file, and it's going to take some time. One of the things I noticed about it right away is that it appeared to be very evidence-based in the way that they eliminated certain areas of employment versus others. So they appear to be taking a measured and informed view of how they're going to reform the program. And it's also, when you talked about trades, Ben, these new rules apply to the non-degree programs, and so there may be some knockoff effects from hitting those types of students who can do that type of work, because people in degree programs are completely exempt from that. They may not be looking for the same kind of work, but the thing I like the best about it is that it appeared to be based on evidence, which is something new.
It's not based on feelings. Chris, is this a case of, look, we have to make a decision like this, and if it has a negative follow-up effect, so be it. It just means that those industries, like the colleges, they have to adapt. They have to figure out how to work in a world where we right-sized the work permits situation.
That's some of the ABC voltage remaining. I tuned the radio a bit. I should go up and down.
The story of the last.
See how that works? Fantastic.
The fact that they have had nobody consistently step up and be that rotation presence behind Crochet, never mind finding, 2 through 5, they haven't found anybody really. And that has been,
and they needed to, hit it head on. And I think that's what they've done. And you guys all know this. There's no easy solution when it's, when you're taking broad strokes at this from a government perspective. But I think in this regard, they have been fairly tactical, and it's a good first start.
Warren, I think the greatest compliment I could give our new Prime Minister is that he really does seem to have the capacity to keep a lot of balls in the air. There are a lot of crises that he is trying to solve simultaneously, this being one of them.
Yes, for sure. But for the hopefully few people who are going to be sitting in hospital emergency rooms on this long weekend or almost long weekend, waiting for a doctor or waiting for a nurse, keep in mind this.
Downtown, 19 at Pearson, 680 News Time, 10:54. Have more summer adventures and save over 30% on the 500-watt gyrocopter now in e-bike. Today's showstopper at tsc.ca.
The radio's actually working quite good. French here.
Vous avez très bien répondu en tant que non, mais il n'y avait pas de
bonne lightning. Yes, big storm's coming. We'll have to take a peek at the radar in a moment.
Year and a half of.
Well, okay, I think I'm just playing around now. Let's shut this off. Here we go. Shut this off. Okay, well, isn't that something? So we got a radio here with a lovely cabinet. It's a nice radio. It works well. I haven't even done anything to it yet, and it's working quite well, except for one problem, one bad problem, and that's the output transformer here is pooched. It would be a shame to abandon this radio and just say, well, that's it. It's never going to work again. If the cabinet were beat up and if it was in really bad shape, well, maybe this would be the end of the road for it. But look at the cabinet of this radio. Other than a little bit of dust on it here, it's in beautiful shape. This is intact. It is missing a knob, but I've got replacement knobs I can put on there. So I don't really want to tell the owner of this radio that it's a shelf only radio when it's so close to working. Just one problem needs to be solved. Okay, let's take a peek at the weather, and then we'll see what kind of storm is in store for us here in Ontario. This is the Canadian government weather website. This website often breaks down. So, whoa, okay, so I live right here. This is about a 20-minute drive to Bracebridge here, Parry Sound and Huntsville, very popular northern communities. They're getting smashed, and we got nothing. And it's often the case. We sit here in Aurelia, and big storms go rolling by just north of us. Let's play this, get an idea of the direction of things. Seems to be kind of up this way. So it looks like, according to the weather report, 6 o'clock tonight is when we get hit by heavy rains. Let's just back out here and look at the total extent of this storm. So what's going on here weather-wise, as I understand it, is there's high pressure down here in the United States, and it's causing a flow of air to come up this way. and this is encouraging large heavy storms. And I believe there's been quite a few tornadoes down in the States in the last couple of days down in this area. I'm not sure. Yeah, but there are tornado warnings up in here too, up in this area. That's the weather report. And do I have the smoke report handy? I think I do. Smoke report. And so this is a forward-looking smoke thing. Most of this is in the future, and this whole thing is done by calculation. It's not by measurement. You can see that what they're predicting is a big clearing, and then it goes away. But I'm right here. This is important to me because I'm looking for nights where I can go out and do some astronomy on my deck, and we get enough of this smoke in the sky, it does occlude, is that the right word? The fainter stars. You can't see them anymore. Looks good. Okay, that's great. Enough of the weather reporting stuff here. Okay, so what I'm likely to do, the owner of this radio has given me another radio to look at, a European style radio. So I think I'm going to set this one aside for now, ponder this situation. I'll look around my house more to see if I can find some kind of alternative. I've even heard of people using wall warts here, which kind of blows me away, but really? Could you do that? A wall wart? I personally, no, I don't think so. But okay, yeah, that's it. See you on the next video. Have a great day.